All right, so let's measure clutch pack clearance. So we need clearance inside of our clutch pack, which is inside of here, so that the little clutches pieces can spin. So these, unless the clutch piston has pressure behind it and is engaged, these should be able to spin nice and freely so that that gear is not trying to apply. Because if we try to apply two gears at the same time, the transmission will lock up. So we need to make sure that there's enough clearance there that they won't drag and cause that lockup, but not so much that the piston will overextend and blow out, like if you wore brake pads down to all the way through the backing and the piston of the caliper falls out. Kind of the same situation there. So I've got my handy dandy dial indicator hooked up here. I'm going to zero it out. I always like to do this a couple times just to make sure that the fixture is nice and held steadily. We'll pull up. And what did we go up to? 34. Now, each graduation of our dial indicator is 1,000th. You can see right here it says 1,000th of an inch, and that's each one of these notches. So what we saw is we started here, and it went up to just about, let's try that again. Started here, and it went up just about to right there. Alright, so just about in that 34 thousandths range. It's important that when we set the dial indicator up, put it back in the fixture here. It's very important that when we set the dial indicator up, see at the top how I have some of it extending? If this bottomed all the way out and we zeroed it there, it wouldn't really be telling us anything. So let's double check this. What we're going to do is then turn this 180 degrees-ish, so right about there, zero it out, and we'll do the same thing again. And what Ford will tell you to do is take those two measurements. So the first one was 34 thousandths, 0.034. The second one looks like it's coming up to almost the same. We're at like 33 thousandths, 0.033. So what Ford tells you to do is measure one side, measure the other side, take an average. So you add the two together, divide by 2. And that way, if for some reason we're not able to get into a certain clutch fixture quite easily, we're going to end up with a more accurate measurement, just like how with data collection, the larger number of data points you have, the more accurate you're likely to be. So we're twice as likely to be accurate doing it this way than we would have if we just did it the traditional way, which is measure one spot and call it good enough. Okay? So 34 thousandths. We'd end up going to our workshop manual, looking at specifications for whichever clutch assembly out of the transmission this one was, and see if we're in range. Now, what sets that clearance, take my snap ring in, what sets that clearance on some transmissions is the actual thickness of this snap ring. So if we had too much clearance, we would thicken the snap ring. If we had too little, we'd try to make it thinner so that there was a little bit more air gap in there. On many transmissions as well, I would argue just as many as have what they call a selectable snap ring, we have a pressure plate. So this is the plate that the piston pushes all the clutches up against. So all the pressure ends up hitting on this plate. On some transmissions, this is selectable, so it could be thicker or thinner. And on this transmission, this is the selectable component. You see how thick this bad boy is. So what's really happening when we take this measurement, and say we were like some high-speed transmission designer or something like that, is we put the snap ring in, and we would want to measure our entire clearance. So no selectable in there. So we would measure our entire clearance. Give myself some room because this is going to be a lot. So, and you can see all the air gap that's in here. So we pull up. one time around, 2 times around, so that's 0.1, 0.2, right? 3 times around, so that's 0.3. And up to, it looks like 72. So again, this little gauge on the bottom should count our times around the sun, but nonetheless, 1, 2, 3. This time I'm at 0.75, so 3 points, or 0.375. And we'll do the same thing, give it a 180 turn. You can see that I'm actually measuring on a wave plate, so I want to make sure I'm on the low spot of this wave plate. See, if I go one way, it goes down and then it starts to come back up. So let's make sure I'm on that low spot. I'll zero this out again. 1, 2, 3. That time it's 0.77, so we'd call it 0.376, right? That would be between 0.375 and 0.377. And so that tells us what my total amount of clearance is there. Then we would find what the clearance is supposed to be. So let's say it's supposed to be that 33 thousandths that we just found. We would take the 33 thousandths, subtract it from the 0.375, or I guess, what was it, 0.37, or 0.376, and that would give us what our selectable is supposed to be. So, because this is definitely a lot thicker than 0.3 anything, right? Way thick. All right, so let's do that one more time. My total clearance, when I averaged it out, was 0.376. That's a mile and a half in transmission world. So if I need to figure out what selectable will go in this, and the reason why this selectable might change is maybe the clutch burnt up and wiped this thing out and it's hurt, and we're not sure if the new one that we're putting in, we're not sure what size this one was, so we got to figure out what new one to put in there. We may also have replaced this drum assembly that houses the clutches, and with slight machining variances and things like that, we may need a different size selectable. But nonetheless, if you don't know what needs to be in there, we measure the entire amount of the clearance, we figure out what the spec is supposed to be and subtract that spec from it, from the total amount. And that's whatever's left over, right? That's the area that we need to take up with this thing. So entire clearance minus what's supposed to be there gives me what I need to put in there to take up that slack. All right.